Have you ever wondered what empty space really means? Close your eyes and imagine a vast, endless void, a stretch of nothingness. Now, what if I told you that this emptiness is actually teeming with energy? This revelation isn't science fiction. It's cutting-edge physics. And today we're diving into the bizarre and mind-bending world of the quantum vacuum. Let's start here. In our everyday lives, we think of empty space as the absence of matter. No atoms, no molecules, just nothing. But at the quantum level, things couldn't be more different. And here's the real shocker. That so-called empty space might just be overflowing with an unbelievable amount of energy. So what exactly is the quantum vacuum? Quantum physics tells us that even the most barren parts of the universe aren't completely empty. They're filled with tiny bits of energy, fluctuating wildly. These fluctuations are what we call quantum vacuum energy. Scientists describe them as particles appearing and disappearing, like fireflies flickering in the dark in a constant and never-ending dance. But why does this happen? To explain, let's introduce one of the most groundbreaking principles of quantum mechanics, the Heisenberg uncertainty principle. Simply put, this principle tells us we can never know both the exact position and momentum of a particle at the same time. This uncertainty creates a constant state of flux, even in a vacuum. What this means is that even empty space has an energetic hum, a vibrant pulse of activity that defies our classical understanding of nothingness. Now, let's talk about virtual particles. These are particles that pop into existence from this vacuum energy and then vanish just as quickly. They're called virtual because they're not quite like the particles that make up everything we know of, like atoms or molecules. They exist for such a brief moment that we can't observe them directly, yet their effects can be measured and felt in profound ways. For instance, the Casimir effect is a fascinating phenomenon that directly proves the existence of quantum vacuum energy. When two metal plates are placed very close together, the space between them interacts with these virtual particles in such a way that the plates are pushed closer together. This might sound strange, but it's been observed and confirmed in experiments. Think about that. Two solid objects moved by the energy of empty space. But we're just scratching the surface. Quantum vacuum energy is more than a curiosity. It could be the key to unlocking some of the greatest mysteries of our universe. For example, scientists believe that vacuum energy might play a critical role in the expansion of space itself. In fact, some theories suggest that the universe's rapid expansion, something astrophysicists call dark energy, might be tied to this quantum vacuum energy. And there's more. In particle physics experiments, scientists have harnessed this vacuum energy to produce incredible phenomena, like particle-antiparticle pairs coming into existence and annihilating each other. This is known as quantum fluctuations, and it's at the heart of how our universe essentially generates particles out of almost nothing. It's like pulling rabbits out of a cosmic hat. Okay, let's stop and consider the implications. If empty space is brimming with energy, could we ever use it? Theoretical physicists have speculated about tapping into quantum vacuum energy, and some hopeful thinkers even propose it could serve as a limitless source of clean energy for the future. Imagine powering entire cities on the energy of nothing. A science fiction dream? Possibly. But every great leap starts with such dreams. Now imagine this. It's not just science labs or deep space where this is relevant. Quantum vacuum energy is happening everywhere, around you, inside you, and through you right now. Though we don't notice it in our everyday lives, its omnipresence underscores how our universe is fundamentally different from what our eyes perceive. Let's circle back to the vastness of space, where this truly gets mind-blowing. Deep space serves as the ultimate testing ground for such phenomena. Despite stars, galaxies, and cosmic dust that occupy parts of space, most of it is still a vacuum. Yet this vacuum is charged with energy. This paints an entirely different picture of the universe. The void isn't a barren wasteland, it's an active participant in shaping cosmic events, from the bending of light near black holes to the birth of subatomic particles. Speaking of black holes, their interaction with quantum vacuum energy brings us to one of the most fascinating concepts in theoretical physics: Hawking radiation. Proposed by the famous physicist Stephen Hawking, this idea suggests black holes can emit energy through quantum processes involving the vacuum near their event horizons. This could slowly evaporate black holes over time, redefining what we thought we knew about these cosmic giants. But let's bring things back to Earth. Quantum vacuum energy challenges almost all of our traditional ideas about reality. The notion that nothing can actually contain something forces us to rethink how we define existence itself. There's artistry in this invisible energy. It shapes the universe, sustains particles, and maybe, just maybe, holds the code to our future technological breakthroughs. As you reflect on this, take a moment to reconsider how you perceive the spaces you encounter every day. The air around you, the sky above you, the vast stretches between stars. None of it is truly empty. Instead, it's alive with possibilities. And there you have it, the quantum vacuum, where emptiness turns into a spectacle of constant creation and annihilation. We've journeyed into a reality where nothing becomes everything, and the boundaries of human understanding are pushed to their limits. The next time someone mentions empty space, you'll know the incredible truth behind it. So the next time you look up at the night sky or even just pause to consider the spaces around you, remember, there's no such thing as nothing. Where emptiness exists, so too does infinite potential. That's the quantum vacuum in all its dazzling mystery. Isn't our universe astounding?